Technology on the horizon. Innovation is essential to delivering an integrated energy system that will realise our net zero future. We're turning a technology vision into action, developing and deploying breakthrough technologies that have the potential to transform the energy industry. Let's take a closer look at the cutting-edge technologies and projects on the horizon. Technology on the horizon. Technology 1. Energy hubs. The UK currently produces 8.5 gigawatts of wind power, with plans to increase the output to 30 gigawatts by 2030 and 80 gigawatts by 2050. To achieve this goal, multiple energy hubs in strategic locations around the UKCS will be needed. Energy hubs will combine operation, production, storage and transport. These are cornerstones of an integrated energy system and essential for the transition to net zero. The hubs will produce clean energy by connecting renewable energy sources such as wind, tidal and hydrogen. They will play a key role in decarbonising ongoing oil and gas operations, creating a circular economy by repurposing existing infrastructure where possible, producing hydrogen at scale, and providing alternative fuels for vehicles and marine vessels. Creating clean energy hubs across the UK will contribute 60% towards the country's overall net zero targets by 2050. They will provide 5% of the UK's low-carbon energy by 2030 and 12% by 2050. With a potential gross value add to the UK economy of between £31 and £220 billion. Technology 2. Co2 Circular SmartDAC. Most carbon capture techniques focus on removing emissions at source to prevent the harmful gases reaching the atmosphere. These techniques work well for heavy industry like iron and steel, but these industries only account for 30% of total emissions. The other 70% comes from distributed sources like cars, aviation, shipping and agriculture, where it is impossible to capture carbon at source. Using membrane gas absorption and electrolysis regeneration, the SmartDAC system separates the CO2 from the air, creating a continuous absorption regeneration cycle. The CO2 captured can be reused as a carbon source for sustainable chemicals and synthetic fuels to replace fossil fuels and create a short carbon cycle, or stored to remove CO2 from the atmosphere permanently. Using wind circulation to push air through the system and being powered using green energy, SmartDAC is a zero-emissions solution for CO2 capture. With an estimated 10 gigatons of CO2 removal per year required by 2050, potentially doubling to 20 gigatons by the end of the century, direct air capture technologies will play a key role in delivering net zero objectives through mitigating CO2 emissions. The scalability and sustainability of the SmartDAC system makes it an affordable solution to small, medium and large-scale capture of CO2. Technology 3. Hydrogen backbone. Pipeline system repurposing for hydrogen transportation. The UK government has doubled the ambition for hydrogen production to 10 gigawatts by 2030. Hydrogen transport and storage infrastructure is essential to growing the UK's hydrogen economy. Over 10,000 kilometres of offshore pipelines are installed on the UK continental shelf. Repurposing some of this existing infrastructure will provide a significant opportunity to accelerate hydrogen transport. The offshore hydrogen backbone project will lay the foundations for a hydrogen export pipeline network, linking proposed energy hubs across Scotland with centres of demand, repurposing and optimising existing gas pipeline infrastructure, both on and offshore. The project will connect to existing national grid infrastructure, linking ports and other assets. Setting sites beyond the UK, it will connect to the European offshore hydrogen backbone as part of an extensive hydrogen transport and distribution system. Reusing existing pipeline assets to export hydrogen will accelerate the delivery of a hydrogen network as well as reduce CO2 emissions from pipeline decommissioning. Hydrogen will be used to decarbonise the UK's industrial clusters and deliver reliable, affordable and decarbonised energy for homes and businesses. It is estimated that this innovative project could support up to 800 jobs and contribute toward establishing a hydrogen economy that is estimated could support up to 100,000 jobs.